Hi guys, today is day 2 of understanding quadratic functions. So again, we're going to take what we did on Friday and we're going to step it up a bit. So again, you got to remember, what is a quadratic function? It's basically a function that can be represented in the following form. Here we have ax squared plus bx plus c. Now again, we've been working with this kind of stuff. On Friday, we only worked with the very first part here, the ax squared. Today, we're going to add, your b and your c, and we're going to see how that affects the parabola. And again, I know it's a quadratic because it's x to the second power, so I should be getting that u-shaped parabola, but these numbers are going to do the 4, the 3, the 6, the -5. They're going to start doing things to the parabola, and we want to see what happens there. Right, so let's take a look at our first example here. I have the function, the quadratic function, y equals x squared plus 4x plus 3. Now, again, I want to use that table of values, exactly what we did on Friday. And again, I want to fill in my y column here. So I'm going to start by taking my my -3, which is my x value, and I'm going to substitute it wherever I see an x. So I get -3 to the second power plus 4 times -3 plus 3. And again, I want to simplify that so that I can get the y value. So -3 to the second power gives us -3 times -3, which is positive 9. Now, positive 4 times -3 is -12. Bring down my plus 3. If I continue to simplify, 9 minus 12 gives me -3. And -3 plus 3 gives me 0. So again, when I substituted -3 for my x, my output, my y value here was 0. All right, and I'm going to continue to do this. I'm going to pause it here so I don't waste time. And I'm going to continue filling in the rest of these y values. What I went ahead and did was I took each one of my x values and I plugged it in. So I literally went down my list: -2, -1, 0, 1, 2, 3, and as you can see, here's -2. When I plug it in, I got a -1. When I plugged in -1 here, I simplified it and I got 0. When I plugged in 0, this is where we see it, my output was 3. When I plugged in 1, we come back up here and I got 8. When I plugged in 2, and again we can see it here, 2 to the second power gives you 4. 4 times 2 gives you 8. You bring down your 3. 4 plus 8 plus 3 gave me 15. Lastly, when I substituted 3 in, I got an output of 24. Now this is great, but I haven't graphed it yet. Now I have to go and create a coordinate plane. So that's what I need you guys to do in a second, and we'll start graphing this. On my board, I have my table of values, which is going to help me right now graph, and I have my coordinate plane here. So again, we're going to start off with number 1. So it says -3, 0. So again, that means I go left 1, 2, 3, and I'm actually going to stay there. I don't rise or fall because of that 0. Next one says -2, -1. So I go left 2 and then down 1. Okay, next one is -1, 0. So I go left 1 and I stay at 0. Okay, next one would be 0, comma 3. So I stay at 0 and I go up 1, 2, 3. Right, I can actually already start to see my parabola form. The next one would be 1, comma 8. So I scoot over 1 and I go up 1, 2, 3, 4, 5, 6, 7, 8. All right. Now again here, guys, if I tried graphing 215, that would shoot way out of my screen here. 324 even more. So I'm actually gonna stop right there. I'm not gonna plot those last two. But again, we already see that parabola start to form. And here's the thing. This is why I said those parts of parabola are very, very important. I can see that my axis of symmetry. Let me try out in a different color here. It's actually gonna happen right here. Hopefully you guys can see that. It's going right through the middle. And because I have that axis of symmetry, I can actually complete the other half of my parabola. So I know that my parabola starts here. It's coming down, coming down, coming down, shoots back up. Now again, to get the rest of this parabola, what I want to do is, again, let me go across 1, 2 to my axis of symmetry. Let me go across 1, 2. That should be where my next point falls. I'm gonna go up to the same level up here. And this is over 1, 2, 3 from the axis of symmetry. So let me scoot over 1, 2, 3 on the other side. Okay, just by, again, I can kind of cheat it. If I have half of the parabola, I can connect now the other half. Let me fill this in. And here we go. We can see the parabola. I'm gonna fill this in a little bit darker so you guys can see it a little bit better. All right, guys, so here it is, nice and neat as possible. What I want to do now is I want to talk about the special parts. I want to analyze this function. And we're going to start again with my vertex. Again, vertex is where the parabola changes direction. So if I follow this, it goes down, down, and then shoots back up. But from now on, I actually want to start naming this point. So again, I need to find the coordinates for that point. I know I start at 0, 0. I start at my origin. I go left 2, and I go down 1. So I know I went left 2. So that's going to be, my vertex is going to be at -2, comma, -1. All right. Now, to get the axis of symmetry, the way that we write that is we basically want to figure out through what x value does it cross. So again, what x value am I crossing through? And again, if I follow my axis of symmetry, if I follow it down, follow it down, follow it down, I hit here, and I know that this is -2. So my axis of symmetry is going to be x equals -2. That's the way we want to write it. And hey, it actually matches up with the x value of the vertex. So that's a big hint. I can give you guys these two values should always be the same. Now, the x-intercepts. These are going to become very, very important. Another way to say x-intercepts would be to say roots or solutions. These 3 different ways to say the exact same thing. Again, I want to figure out where does it cross the x-axis. All right, and I'm going to take a look at this very first point here. So let me label this vertex so I don't accidentally confuse it with anything else. Here is my first x-intercept. That's where the parabola is crossing the x-axis. And this is going to be, I go over to -1, and I stay there at 0. So this one is going to be -1, 0. Let me write it over here. -1, 0. That's my first x-intercept. Now the other one, if I scoot over here, let me label this one. This is going to go over 1, -1, -2, -3. So this is actually going to be -3, 0. So these are my 2 x-intercepts. These are, again, you can call them roots, you can call it solutions. So again, kind of get used to it, get comfortable with it, because they will ask it all 3 different ways. Now the last kind of critical point here is going to be my y-intercept. So again, now we're looking vertically. Where is it going to cross my y-axis? And it crosses at this point right here. Now to get to that point, again, I stay here at 0, and I'm going to have to, I don't go left or right. So again, my x value is 0, but I have to climb up 1, 2, 3. So it's going to be 0, 3. That is going to be my y-intercepts. Now, why do we need these critical points? It's going to be so much easier. I'm going to show you guys the shortcuts this whole month on how to graph the parabola and avoid using that table of values, but we need to understand what the vertex is, where is the axis of symmetry, what are the roots, what does it mean by y-intercept. If we can get these points, it's going to make my life easier when I want to graph a parabola. Already cleaned it up here, and I want to talk about the other characteristics and other important pieces of a parabola. So again, number 1 would be, well, what way does it open? And again, we can see that this is opening upwards. It's kind of like a happy face. So again, this is opening up. I'm just going to circle that there. If you want to put right next to it, opens upward. Now here's the tricky one. Max or min. So if I follow this parabola, you notice it has arrows up top. This means that this actually goes on forever to infinity. It shoots up, does not stop. So it's never really going to have a max value because there's always going to be something much larger than it. But if I follow this, if I follow it all the way down, I hit the bottom here of my vertex. That's actually, you can think of it as kind of the bottom of a ditch. So this is actually my lowest point. It has a minimum value. So we're going to say it has a min. As far as domain goes, domain is asking us, well, what are all the x values that are shown? What are all the possible x values? And actually, again, these arrows are very important because this goes on forever and ever. That means that all my x values will always be shown. They're going to be part of my parabola. So again, what we're going to say for the domain is it's going to be all real numbers. And we're going to use this fancy R right there. As far as the range takes a look at all the y values. So again, I'm going to write y here. And if you guys notice, this parabola stays above a specific y value. If I go right here, the parabola never falls below that. So I want to figure out what that y value is. And that's actually, that y value is -1. Okay, but is a parabola greater than, or is it less than that value? And again, we know that this is above it. So we're going to say this is greater than or equal to -1. That is going to be my range. I have the quadratic function y equals -x² plus 6x minus 5. And the reason I wanted to do this one with you guys is because that little negative sitting on it front, that tends to confuse people, and actually it's going to do something very, very special to my parabola. So what I want to do is I'll do the first one real quick, just like last time. So I'm going to plug in, again, I'm going to break down my negative. Don't forget to bring down that negative. And then parentheses, I'm going to put -3 squared plus 6 times -3 minus 5. Now this is the tricky part because I have to do the exponents first. I have negative 3 to the second power, which is positive 9. So I bring down that positive 9, but that negative, I still have to bring that negative that was outside down. So it actually turns it back into a negative 9. Now here we have 6 times negative 3, which is negative 18. And then bring down my minus 5. Negative 9 minus 18 is going to give me negative 27 here. And I'm going to bring down my negative 5. So negative 27 and negative 5 is going to give me negative 22. So that is my y value. What I'm going to do is I'm going to pause it here, and I'm going to complete the rest of these values to get all my y values. This was actually not negative 22, was actually minus 32. All right, so I continued and I finished off the rest of it here. But if you guys notice, these are very, very large numbers, minus 32, minus 21. So what I'm going to do is I'm going to do an extra 2. So I'm gonna add 4 here. I'm going to add 5, and I'll show my work down below. You'll see why I did it in a second. The 4 here, and again, my output value was a 3, and when I did 5, I got 0. So again, the reason I wanted to do those, negative 32 is way too out there to graph. Negative 21, even negative 12 is kind of a little rough. So let's see what happens. I'm going to replace these top 2 with 4 and 3 and 5 and 0. We'll see what kind of picture we get in a second. Negative 3, negative 32 is not going to work, so it's not going to fit. So I skipped that one. Negative 2, negative 21, I skipped that one. So these two, I crossed them off right there. I only had enough to go down to negative 10. So went ahead and, well, not even negative 1, negative 12 fit. So I moved on to 0, negative 5, 1, comma 0, 2, comma 3, and then 3, comma 4. But if you notice, I can't even see my parabola. I only have this weird kind of curve. I don't know if it starts to curve back down yet, or whether it does something funky. So again, it's always nice to have extra points here. I have 4, 3, so I'm going to go over to 4. 1, 2, 3, 4, up 3. Right, and you notice now, there we go. I actually start to see that it's actually turning back around, coming back down. The next one was 5, comma 0, 1, 2, 3, 4, 5, 0. And again, what I'm going to do right now is complete my parabola by using that axis of symmetry. All right. So what I want to do now, again, analyze it, go through it again, and spot all these important key parts. So let me start with my vertex. Now, my vertex on this one is kind of weird because this parabola is actually facing out. And again, the reason for that was because of this negative a at the very beginning. When you ever have a negative at the very front like this, it's actually going to turn your parabola upside down. So again, let me spot this vertex here, right, the tip top right there. I go over 1, 2, 3, and then up 1, 2, 3, 4. So this is actually going to be at 3, comma 4. And based off of that, I can already get my axis of symmetry. That line, again, it's where does it cross through the x-axis? And I know I'm going to just simply take it from my 3 here, from my vertex. And again, as we can see, it crosses, it goes down, and it crosses the x-axis at. So again, that's my axis of symmetry. Now my roots, again, where does this cross the x-intercept? So it crosses here at this point, and it crosses at this point over here. So again, let me take this one on the left first. This is going to be over 1, and we stay at 0. So this is 1, comma 0 for my roots, solutions, x-intercepts. Again, it means all the same thing. The next one, it's going to be over 1, 2, 3, 4, 5. So it's going to be at 5, comma 0. Now my y-intercept, if I go down vertically now, my y-axis, my y-intercept is this one right here. So actually, let me draw these lines so you can see where I'm getting these values, or where they're actually going. And then this is my vertex. All right. Now, as far as my y-intercept here, it is crossing. I stay at 0. Okay, I don't go left or right, but I simply go down negative 1, negative 2, negative 3, negative 4, negative 5. Talk about again whether does it open up or down. And again, this one is a frowny face, so it's actually opening down. So again, make sure you label that as down. Now, does this have a max or a min? Again, I always like to think of it, I'm walking, I'm going up the hill, and I reach the top of the mountain right here. So it's actually going to have a maximum value. As far as domain goes, again, it's all the possible x values. Again, this goes on forever and ever. So it's going to be all real numbers, and we use this fancy little r here. Now, again, as far as the y, the range, it's my y values. Notice this never goes above this y value right here. So that y value is actually going to be 1, 2, 3, 4. So my y is going to be y is less than or equal to 4 because, again, it's below that value there. graph the following three quadratics. So it's three problems, but once you're done graphing them, I need you to do this exact same thing. Find the vertex, AOS, and the right